If you'll remember from yesterday, what I asked you to do on this page right here on the single transformations is to attempt this. I asked you to try it, correct? Okay, so for those of you who did, thank you very much. For those of you who didn't, shame, shame, shame. Okay? As we're filling this out together today, if you have something written that is very similar to what I have, don't erase yours. Okay? What I would ask you to do, though, is make sure you have the correct vocabulary on your paper. Okay? Okay. The next thing I need you to make sure you understand is the difference between inside and outside. If we look at this function right here and I say, is the A inside or outside? What is it? Inside. Do you see how it's inside the function? And what's this one? Outside and this one? Inside and this one? It's outside. Even though it's in the front, it's still outside the function, right? Okay? So at the top of this page, I would like you to write down the vertex form of a parabola. I know that you don't know that yet. That's where we're going next, so that's why we're going to use this particular formula. Okay? So looking at this particular formula, is the A inside or outside? Outside. Is the H inside or outside? Inside. And is the K inside or outside? Outside. Okay? So we're going to start up here talking about this form, and we're going to transfer that down to these down here. Is anyone else seeing that, or is that just my eyes? Can you see the pencil moving like crazy? Like a shadow or a follow? Okay, just making sure. Okay. Let's start right here. Is this inside or outside? You said inside, right? What direction is something going to move if it's inside? Well, guys, what word starts with the letter H? Besides hunter, horizontal. Okay? So if something's inside the parentheses, which direction is it going to move? Horizontally. So this is going to be a horizontal. Well, this right here in this particular case, this is being added or subtracted. Stop talking. This is being added or subtracted in here. So we're talking about a horizontal shift. Okay? A horizontal shift. Now, think back to the worksheet from yesterday, the Combined Transformations worksheet. If I had x minus 2, which way did it go? It went right 2. If I had x plus 2, which way did it go? It went left 2. Does that seem logical? What does it seem? Opposite. It seems opposite of what it should be. Okay? Something else I need you to know about this document right here that we're working on today is that it is a work in progress, which means I'm not going to write down everything today that I need you to know about this equation or this one or this one. We're going to come back and add stuff as we get to it. It's not that I don't think you can handle it all today, it's just not necessary today. Deal? So we're going to need to come back to this worksheet and add stuff to it every so often until we finally get all the information there. Okay? So what about this one? If it's inside, it's horizontal because there's an H. So if it's outside, it's going to be vertical. Right? Vertical. It wasn't my idea to make this a K. Nobody asked me. I was not even born. Okay? But we use a K, so we're going to say H is going to be horizontal and K is going to be the vertical. Okay? But it's something being added or subtracted, so it's going to be a vertical what? Very good. Vertical shift. Again, remembering your F's are important. Okay? Right now we're going by the A, because that's what's different from the parent function. Okay? So is this opposite or is this normal? Because if it said whatever function plus 5, then we moved up 5, didn't we? Or if on this function it was minus 2, we moved down 2. Does that make sense? Okay. So on number 3, first of all, do you see how 1 and 2 are kind of similar? Something's being added or subtracted either inside or outside of the function. Do you see that? What do you notice about 3 and 4? They're multiplying, either inside or outside, but it's a multiplication. It's a multiplicative property here. Okay? So if it's inside, what's supposed to be happening? Not quite. A horizontal, something horizontal, okay? But it's not going to be a shift because it's inside, it's going to be horizontal. It's going to change the shape, okay? This one changes the position where it is on the graph. These are going to change the shape. So it's either going to be a horizontal stretch or a horizontal compression. Okay? Does that make sense? Again, this is not the only thing we're writing on the page. I just need to get the beginning stuff down and we can focus on stuff later. Is that going in and out of focus or is it my eyes? Great. Okay. So what about this one? What's going to happen here on number 4? It's going to be vertical because it is outside, right? Vertical. And it's going to be a stretch or compression. Why? Because it's a multiplier. Very good. Okay, now 5 and 6. Remember, 5 and 6 are the only ones we're going to look at today. After 1, 2, 3, and 4. We're just not going to look at 7 and 8. What's happening on 5 and 6? How are they related? There's a negative, right? Okay. But on 5, the negative is inside. And on 6, the negative is outside. Okay. So if it's inside, what's inside do? So it's changing some way this way. Do you remember what a negative causes the function to do to begin with? It causes a reflection. Okay. A reflection. But we have to reflect it over something. If it's moving this direction, it's moving over the y-axis. Does that make sense? Now, sometimes people have an issue with that because that's the y-axis right there, isn't it? And the y-axis is a vertical axis, isn't it? But if I'm moving something back and forth this way, isn't it going over the y-axis and not the x-axis? Okay? So what about this one? What about number 6? It's something vertical, so it's moving this way. So what is it reflecting over? The x-axis. Very good. Any questions so far? Okay, that's all we're going to do on this today. Right? Like I said, we will add some more stuff as we go. I would like you to take out the worksheet called Traveling with Parent Functions. Okay? Or just Traveling with the Parents, I guess is what it's called. Now, for the record, this is not talking about traveling with your parents, although I'm sure some of you have some great stories about that. Okay? This is traveling with the parents, and so you know we're talking about parent functions, yes? Okay? So here we go. What parent function are we talking about here? Anyone? What's that called? Square root? What's the other word I taught you the other day? Starts with an R. A. D. I. Radical. Okay? It's a radical function. Okay? Now, we're also talking only where the domain is x is greater than or equal to 0. Well, that's fine, because isn't the domain of this function to begin with x is greater than or equal to 0? Yes or no? Of course, right? So let's fill in this table so we know what we want to get some specific points to graph. Okay? So if I say x is 0, then what is the square root of x? 0. If I say x is 1, what is the square root of x? 1. If I say x is 4, what's the square root of x? And if I say x is 9, the square root of x is 3, right? So let's plot those points on this graph right here. 0, 0, 1, 1, 4, 2, and 9, 3. Can I connect these points? Is this a continuous function or a discrete function? There's an equation, so it is continuous. You remember that? So yes, I want to connect it. Okay? So it tells us already that the domain is x is greater than or equal to 0, so tell me, what is the range? Remember, domain is how far left does it go and how far right does it go. Range is how far down it goes and how far up it goes. So how far down does this graph go? To 0? And how far up does it go? Forever, right? So my y values are greater than or equal to 0. Questions? Use a different color. I'm going to use red for this one. To sketch the graph of the family member that results when the parent function is translated -3 units vertically. Well, first of all, which direction is vertically? Up or down? Which way am I going? Why am I going down? Because it's -3. So that means every point on this line needs to be moved down 3. Very good. From here, down 3. From here, down 3. From here, down 3. And from here, down 3. Okay, so far? Determine the domain and range of the resulting function. So basically determine the domain and range of the red function, right? Well, what's my domain? How far left does this red function go? To 0. How far right does it go? Forever. How do I say that? X is greater than or equal to 0. Very good. What about my range? Y is greater than or equal to, well, remember we say how far down we go, and you're saying it's -3? Does anybody agree with that? 2 people? More people should, because it's right. Okay? So y is greater than or equal to -3. It doesn't go any lower than -3, and it goes all the way up. Okay? Now, here is the fun part. Write the equation for the new graph. Did I move horizontally or vertically? I move vertically, so is that going to be inside the function or outside the function? Outside the function. Where do I start? I start with the function, right? Y equals the square root of x. What did I do to it? I moved it down 3. Done. Difficult or easy? Good. C, with a different color. I'm going to use blue. Oh, sorry, it doesn't say different. It says third. With the third color, sketch the graph of the family member that results when the parent function is reflected about the x-axis. Well, we're talking about the parent function, right? So the gray function, I'm not talking about the red. I'm ignoring the red. I'm just looking at the gray function. If I'm reflecting it over the x-axis, and this one is one above the x-axis, where does it go? One below. This one's two above. Two below. This one's three above. Three below, right? So what happens with that one? It's on the axis. What happens when I reflect it over the x-axis? It stays on the axis, doesn't it? Okay? So my new graph, my blue graph, looks like that, doesn't it? So let's answer some questions about it. Determine the domain and range of the resulting function. What's the domain? How far left does it go? Less than or equal to 0 or greater than or equal to 0? Domain, I'm talking about left and right. How far left does it go? 0. How far right does it go? All the way. So my domain is x is greater than or equal to 0, right? So what about my range? Is that what you were trying to tell me a minute ago? Because you know it's everything below 0, right? It's everything below the axis. So y is going to be less than or equal to 0. Very good. One last question about the blue function. y equals square root of x is the parent function, right? What did we do with it? We flipped it over the x-axis, which makes it a vertical change, so that negative goes on the outside. Questions? Yes or no? Okay. Please go to the page called Multiple Changes on the Parent Function. Okay? Everybody here? Use the table to help you sketch the graph of the parent function. Y equals log of x. Well, guys, we're not even 2 logs yet. There's no reason you should know how to do this, right? Except, what are you given? A table. Can you graph anything from a table? Yes. So 0 is undefined. How do I graph that? I don't, right? What do I know? That my function cannot be at 0, right? So it can't ever cross this axis right here, can it? Okay, so 1 is 0, so 1, 0, and 10, 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, hopefully you remember from the parent function page that logarithm, it looks something like that, right? Now, it wants us to use a different color. I'm going to use green. Use a different color to sketch the family member that results when the y values of the parent function are multiplied by 3. And then the resulting function is translated vertically 5 units. So we have more than one transformation here, don't we? Okay, so we need to do them one at a time so we don't get them confused. Okay, so first of all, it says that all the y values are multiplied by 3. Do I have a list of y values anywhere? Oh, look, right here. Can I just go multiply all these by 3? What's undefined times 3? Undefined. What's 0 times 3? 0. What's 1 times 3? 3. So I'm going to graph 3 new points. 0 undefined, which I can't. 1, 0. Okay, it's there. And 10, 3. So instead of 10, 1, it's 10, 3. So very, very, very lightly, I'm going to draw that in right there so you can kind of see the shape that it takes. Do you see that? Do you see how it's stretched vertically? It's like I took a hold of it and just pulled it up, right? I stretched it. Okay so far? Next, I have to vertically shift 5 units. Well, which way is that? How do you know it's up? Because it's not a negative number. Very good. So every point, I need to move it up 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Those are the only 2 points of this function I have, isn't it? Aren't they? So I need it to look like that. That's my new function. Does that make sense? So how do I write the equation of the graph? What do I start with? On the very, very basic level, what do I start with? Yeah, y equals, right? It was log of x. Did I have a multiplier? Was it a vertical multiplier? Did it affect the y values? So that it goes on the front. 3 log of x. And then I shifted it up 5. That's a vertical shift, so plus 5. That's it. Can I show you this really fast? Okay, look right here. This is the parent function, y equals 2 raised to the x power. The dotted line is the parent function. What makes it look like the solid line now? What caused that? Does it look like a reflection? Does it look like I took it and did this? Yeah? That's a reflection over the y-axis. So it looks like that because it's over the y-axis. The negative is on the inside. Okay? So get these 3 finished and get the one finished on the front here and the one finished on the front here on Traveling with Your Parents. Okay? Have a great day.